Hi, I'm Clem with the Element 14 community, and with me is Dr. Eben Upton of RaspberryPi, and we have some quick-fire questions from the community. Why is the company and product called RaspberryPi?
Very simple. Raspberry fruit named computer companies, companies like Acorn and Tangerine and Apricot, I probably have forgotten one. We wanted to have a fruit named computer company. Pi is Python. We always have believed, Pi is the intellectual successor to BASIC. It has the same lovely property that Hello World is just print Hello World. Doesn't have a lot of scaffolding around it like it might have in other languages. But unlike BASIC, it has a very high ceiling. So you can go to school kids and you can say, that programming language that you just wrote Hello World in, that is the same programming language that professional engineers at Google are using to build enterprise-grade software.
Oh, that's right. Next question. With Raspberry Pi making waves in AI, we have the AI camera, we have the AI Plus head. What's the next big move in AI?
I think the next big move in AI is the deployment of AI into the world, actually getting value out of these capabilities. It's been an amazing 10 or 15 years for theoretical progress in AI. The confluence of enormous amounts of compute with enormous amounts of data have opened up the ability, a set of tools which allow computers to do things which we previously would have thought were the competence, the province of the human mind, right? That's amazing. There have been some great real-world applications. Obviously, our friend Demis just won himself a Nobel Prize for protein folding using AI. But in general, these techniques are still mostly confined to the lab. I think the opportunity is get them out in the world, get productivity gains. Productivity gains are super important to society. Get productivity gains out of it. And I'm hoping that Raspberry Pi, with our new series of AI products, the AI kit, the AI hats, the AI camera, and running AI algorithms on Raspberry Pi itself, that we can help to contribute to that.
All right, we have the RP2013L and the 2350. So, and this one has a bigger version on the datasheets with 80 pins. So are there any plans for products with these bigger versions?
Right. So we have two packages, as you say. We have the 60-pin package with 30 GPIOs. That's intended to be a broadly compatible replacement for the previous generation RP2040 in its QFN56 package. Then we have the QFN80 with 48 GPIOs. We built the Pico 2, and we will build the Pico 2W and other variants around the smaller package. I think what we're largely doing with the big package, we're leaving that to our partners, our approved reseller partners, our design partners, to innovate around. That's something we've always tried to do. We don't want to suck all the oxygen out of the room by building all the products ourselves. We like to leave some things to the ecosystem. I think the 80-pin package is a natural choice for that.
Oh yeah. We have another one. What do you think about running Raspberry Pi 5 with GPUs?
I think it's incredible, right? And this is all about Jeff Geerling. So Jeff has been incredibly tenacious in trying to find ways to run big GPUs, AMD GPUs, first on Raspberry Pi 4, then on Raspberry Pi 5. I think some of the upgrades that we put into the PCI Express controller in the 5 platform have finally got him over the line with the aid of a lot of hacking. I know he's still kind of wading through the morass, wading through the mire to make this stuff work. But it's been incredible to see a Raspberry Pi 5, a little Raspberry Pi 5 with a big AMD GPU sat on top of it, running PC games with Box 64 and Wine, running PC games at 4K resolution. It's remarkable.
Yeah, it's remarkable.
Yeah.
And we have some remarkable MCUs. We have the RP2040, we have the 2350, but on the Pi itself, there's an RP1. Are there any plans for non-MCU Raspberry Pi silicon?
I don't think we have any plans at the moment. I think the team's very focused on the MCU roadmap. I think what we are doing is we're working to make, there is a compute subsystem inside the RP1 IO controller. It's not it's not a standard subsystem, so it's not what you might think it would be, which is an RP2040 up against the pins as a MUX option. But it does have a lot of compute capability. In particular, it has a PIO. It has a version of our programmable IO PIO subsystem. We're working at the moment doing the Linux software work to expose that PIO subsystem, first as a way of implementing a number of custom protocols which aren't implemented on the hardware on the platform, but later on trying to provide individual users with the ability to run their PIO programs at the other end of that PCI Express link.
Okay, and your favorite project with Raspberry Pi that you've ever seen?
I keep coming back to the Cucumber sorter. I love this. This is now nearly a decade-old project. A very, very, very early example of machine learning on Raspberry Pi. This is an engineer in Japan who's to assist his elderly parents in running their cucumber farm, trained a Raspberry Pi to recognize 23 different grades of Japanese spiny cucumber. I like it because it's an early machine learning application. I also like it because it's a good example of what we think Raspberry Pi does really well, which is to be a piece of glue logic, a piece of Lego that sits at the heart of an enthusiast project that provides a bit of compute, a bit of networking, a bit of storage, and a bit of ability to interact with the real world. So it's a kind of a poster child for a lot of the cool stuff that we have seen people do with Raspberry Pi since we launched it with you guys back on the 29th of February 2012.
Oh yeah, and if you could add any feature to a Pi, if budget and space did not matter, what would you add?
I think probably more networking options, and this is actually, we talk about budget, it is a little bit about financial budget, but it's also really about space budget. What would you do if you could have a Raspberry Pi which was this big and cost a couple $100? Well, maybe you might think about adding more advanced wireless to it, MIMO wireless. You might think about adding faster wired networking and potentially more ports of wired networking. You might think about adding wide area networking, either cellular or some other standard to it. So there are always these things. If you would imagine if we took the brakes off, we could build something very fancy. I think where Raspberry Pi has always succeeded, though, is to very parsimoniously provide the essential elements of a computer and then push some of that functionality off into accessories that either we build ourselves, or as I say, we use this as an opportunity to have our ecosystem, the commercial ecosystem around Raspberry Pi, create value and capture value for themselves.
Yeah. Other platforms just got bigger and bigger. Why did the credit size form factor stick with Raspberry Pi?
I think it's that alignment of size and money. The functionality that we could afford to put into a Raspberry Pi at the target price point could always be made to fit into a Raspberry Pi, into that credit card size form factor. Usually in the evolution of any generation of Raspberry Pi, there's a period of time where it is a little bigger. James Adams, our hardware CTO who designs them all, if you desolder the USB connectors from a Raspberry Pi 4 or Raspberry Pi 5, you'll find JRA, you'll find his signature on the PCB under there. So he always designs them. They always start off a little bit big. I stand behind my contribution, my remaining engineering contribution to Raspberry Pi. I stand behind him with a pointy stick and I poke him with a pointy stick. And then one day, the Raspberry Pi, towards the end of the development process, goes boop, and shrinks down to the classic credit card size form factor.
Want to do like new things with the Raspberry Pi. What do you think is the next big application?
I think the next big application for Raspberry Pi is probably helping catalyze the deployment of AI into the world. These machine learning applications, they're in the lab, they're on the bench. How do we get them out into the world? How do we get some value out of them?